Go, 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 reduce all the copper now. I just made a galvanic cell. I can't wait to go home now. Go, 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 reduce all the copper now. I just made a galvanic cell. I can't wait to go home now.
What even is that?
Okay, a galvanic cell, you have a solid bridge with electrolytes, and you have two metals that donate electrons to make a circuit, and we can use that to create a current to fuel a car.
So what do you want me to get, Mr. White?
I need you to get the zinc sulfate and the copper sulfate.
That's the blue stuff, right?
Yeah.
Okay. Oh shit.
Now be careful, Jesse. This is potassium hydroxide. You know what this is?
No.
It's a base. So if it gets on your hand, you're cooked.
Oh. That's gonna hurt.
Yeah. Okay. So we have our two beakers here, and we have everything we need, right? So this is our zinc metal. The zinc is a good reducing agent, so it's gonna lose its electrons, right? What's a good oxidizing agent that can take these electrons?
Iron? Oh, the copper.
Yeah, copper.
Okay,
There you go,
White.
Jesse.
There you go.
Okay, so the electrons from this zinc, right, are gonna go through and this is gonna accept it.
They're gonna like zap us.
Yeah.
Okay.
Like whatever works for you, alright?
Okay.
Come, let's start weighing.
Alright, Mr. White. Okay, so I have the weighing boats right here. Okay. Here we go. Now just start adding. Come on, what are you doing? What's wrong?
You need to zero the scale.
I don't remember doing that in the class.
Did you pay any attention in my class?
Sorry, Mr. White.
Alright, now you can start adding.
Yo, Mr. White, now I need to stir now.
Come on, Jesse, improvise. Alright, here you go.
Start mixing. So we're creating potions now?
No, we're creating an aqueous solution.
What's that?
Now we gotta make aqueous KOH for our solid bridge.
Don't we already have it right here?
No, we need to have it in the aqueous solution. Yeah. So why do we need a solid bridge anyway?
Yeah, if you said the electrons are going to come out of the zinc and go into the copper, why would we need?
Well, think about it, right? It's a salt, so it's formed of a cation and an anion, right?
Yeah.
So if we have the electrons flowing from the zinc to the copper, right, we're going to need something to complete that circuit. And that's going to be our solid bridge, right? Where the cation and the anion are going to split.
So it's like when I sell you the drugs, you got to give it off to the people. It's like the supply chain.
Yeah,
like
whatever
cycle.
works for you, whatever works for you. You know what I'm
Okay,
saying?
that's right.
Alright. Okay, Jesse, the next step I need to do is create the solid bridge, okay? So don't do anything stupid while I'm not here.
Okay, Mr. White. So guys, let me teach you some chemistry. So here we have the copper, and here we have the zinc. So we're gonna put the zinc into the copper solution, and the copper into the zinc. So then we all
Jesse!
What's wrong, Mr. White?
I told you not to do anything stupid.
Sorry.
Okay,
So what do we actually do?
this is the copper sulfate solution.
Yeah.
You have to read the label.
Oh, that's what that's for.
So the copper goes into this solution and the zinc goes into this solution.
Okay.
Can we give it a try?
Yep.
Let's just interview the youngins.
Okay, so Jesse, this is a galvanometer, right? It measures voltage.
Okay.
So our battery needs 12 volts
Yeah.
in order to power it up and get our RV running.
Okay.
Okay, so if we make 6 cells of these, right?
Do the
Yeah.
first 10
How
minutes of the
much
last
voltage
10
does each
minutes.
cell need to produce?
2.
Yes, Jesse, that's a good answer.
I was
Okay.
listening to math.
Okay, so what we're gonna do is we're gonna connect our alligator clips, and we're gonna see how much voltage it produces. All right?
Okay.
Here you go.
I got this one. I got this one.
You got it.
Coming from
Yeah.
oxidization and that,
Yeah.
reduction and that. Why isn't it working? You're a fraud, Mr. White. You don't even know chemistry.
Jesse, wait a second. You forgot the salt bridge.
Ah.
Oh. Here you go. Salt bridge goes in. What's in here again?
This is KOH.
Yeah, so it's the electrolytes that completes the galvanic cell.
Like the ions. They be
Mm.
going this way, that way.
Yes,
Like
yes,
the
yes.
motion.
Yes. Do you have motion?
Yep. Since birth. Yo, look, Mr. White. We got voltage. We got voltage. Let's go, Mr. White. What's wrong now?
Jesse,
The actual measurement of things, so you get
you don't even have 1 volt.
spectroscopy is just like theory.
It's a lot though, no? We can have 6 batteries. That's like 6, 7 volts.
We need 12 volts to run our RV. Are you serious?
I'm thirsty. What are we gonna do?
It's okay. We'll call our friends to help us out.
Oh, Ian and Barca.
Yeah.
They're chemists, no?
Spectrometry.
Yeah.
Maybe they can help us with the
They're
solution.
Waterloo alumni, and they worked with the infamous Dr. Bird.
Okay, there we go.
They can
there
help
we go.
us
Yeah,
out.
yeah, yeah.
Get
Let's
out
call
of
them.
a
Let's
sticky
call them.
situation.
Yeah, yeah.
Hey, Walter and Jesse. I'm Ian. I'm here with Parsa, and we're here to help you out and reboot your RV.
Yeah, so we saw the galvanic cell you guys made and how it generated less than 1 volt. So today we're basically going to show you how to create a galvanic cell that can actually reach the 12 volts of power you need.
So, in order to calculate the amount of voltage your cell produces, there's 2 equations, as you can see on the left, which is basically the difference in potential between the electrodes. Now, if we do the calculations for yours between the copper cathode and the zinc anode, your cell only produces 1.10 volts, which is not enough if you make 6 of those to get the 12 volts that you need. So Parsa, what can we do to increase the number of volts so that Walter and Jesse can get out?
Yeah, so there's many different things we can actually do, but the easiest thing is to basically create a different cell. So as seen in the last slide, kind of the voltage depends on the cathode and anode individually, right? And it has to do with every element. So if we pick different elements that have, are better reducing agents or better oxidizing agents, we can actually get more flow of an electron and a higher voltage.
Some examples you might find in your RV might be silver or gold, which are better reducing agents. But what might be easier for you is to create more than 6 cells. And by doing this, you can create more voltage just by sheer number. But Parsa, can't we just increase the concentration as well? Because if we increase the concentration, we'll have more electrons produced and more voltage.
Well, that's actually a very common misconception. So people think by increasing the concentration, we can kind of have more reactions occur. But that's not actually true because the voltage calculations have to do with the kind of physical property of each element. So kind of the concentration changing won't really affect the voltage at all.
That makes a lot of sense. Well, that's all we have. Good luck, Mr. White. Good luck, Jesse. And we hope you make it out of the deserts. See ya.